And thank you so much, everyone, for taking the time to join us here today. Really excited for the opportunity to talk a little bit about how we can indeed accelerate product development and optimize engineering efficiency with observability. As mentioned, my name is Chris Harding, and I am a solutions engineer here at Epsagon, where we provide a trace-centric observability platform that is really tailored to providing observability for these modern microservice type architectures. And so let's dive in and talk about a little bit what that means. All right, great. So as it relates to our agenda, we're broadly going to be touching on three topics here. The first of which is this rise of microservices, this shift that we've seen over the past 10 years or so from these very monolithic on-premise applications to these more distributed architectures that are really becoming the norm. And we'll also look at some of the challenges that come with that. We'll talk about what it looks like to create the right observability strategy around these microservice environments, and specifically with an eye towards really achieving critical business level outcomes, right? How does observability enable an organization to really increase their business metrics and provide more value in their product and to their customers? Great, let's dive right in. But before I get started, I should mention we will have a quick Q&A after the presentation. And so if you do have any questions, please drop them into chat and we'll make sure to address those. All right, awesome. So let's start by taking a little bit of a step back and get some historical context related to this evolution of software that we have seen. And so when it comes to really what a primary catalyst or driver for this evolution is, I think we could really look to September 19th, 2006. And so for any of you tech trivia fanatics out there, you'll probably recognize that as the date that AWS was launched. And so at the time, it wasn't really gangbusters out of the gate, but it certainly brought about some changes in how we really look at infrastructure, right? You no longer needed to have and invest large upfront costs in your own servers. You didn't have to have engineers on site any longer. And you could really sort of minimize those costs associated with getting your applications up and running. This coincided, of course, with the Great Recession, where we really saw a lot of these marquee technology companies from today start out. And really what they did was leverage some of this technology within AWS in building out their applications to become some of these sort of business processes that we see in place. It used to be historically for payment processing, it might be something you'd set up yourself, right? For authentication, you would write that code. But we saw a lot of these companies come about, companies like Stripe and Auth0, where now a lot of that is being abstracted out of your code and handled by these sort of managed services. The next step, the next evolution we saw is really around abstracting away that infrastructure, perhaps in totality, whether that's leveraging things like AWS Lambda, or whether it's leveraging container technologies, Docker, Kubernetes, in order to orchestrate these services. And so we've really seen this evolution from having these on-prem servers to these really distributed environments. And that, of course, was one of the bigger catalysts towards this rise of microservices. And so every day we're talking to customers who are at some stage of this journey, right? I think the latest research is something like 85% of enterprises have now defaulted to these microservice environments. And they have a lot of benefits. It makes a lot of sense, particularly as it relates to things like developer velocity, right? By breaking out your monolith into these highly distributed services that can be worked on in isolation, and that allows you to release code more frequently. But of course, with these environments, and as we can see here, they become pretty complex, right? It's no longer just a big monolithic application. You might have services that are talking to message queues and databases and all of these various technologies within those applications. And so while there are a lot of benefits, these new architectures do come with problems, primarily around how complex those environments are, right? And so, when you're working with tens, hundreds, or we have customers with even thousands of microservices, when something does go wrong, it can be incredibly difficult to ultimately pinpoint where and in which service those errors are ultimately being generated from. And so that in and of itself sort of saps away from that increased velocity. That is the big benefit around microservices. And so with this new paradigm, of course, and in more depth, there are these new challenges. It becomes incredibly difficult to monitor all of these various services when you have logs and metrics sort of dispersed into a number of systems, right? If you have a business request that involves 10 services and there's an issue, it becomes very difficult to correlate all of that data, which log lines from service A correspond with which log lines of service B. And so it really is a significant challenge. And then even if you have those data, if you have those logs, you have to be sure that you have all of the information, right? Did your engineers log a sufficient amount of data to really troubleshoot that issue at hand? And so there are some significant challenges here. And so something is missing, right? If we look at some of the traditional tools that go into monitoring, primarily they're focused on metrics and logs. And metrics are great because they can tell us what, right? Metrics let us know that something is broken. Logs can tell us why, what caused that breakage. But how do we correlate data between all of our services? And how can we indeed find that where, i.e. which service is producing that failure? You must be saying to yourself, Chris, there's got to be a better way. And there is, and it very much comes in the form of distributed tracing. Now, if you're not familiar, distributed tracing was largely born out of Google about a decade ago. And so distributed tracing really is the ability to connect every request in your transaction and understand that business request, all of the services that are being used as part of it, and that full end-to-end picture. And so Google engineers, some of the early adopters around microservices, they were having these same problems, right? The same problems we've been talking about. And distributed tracing is actually what they came up with in order to solve that issue, in order to empower their engineers to really find that needle in a haystack, if you will. And so here at Epsagon, we strongly believe that observability in microservices, it's something that can only be achieved by the combination of these three pillars. And so those being, of course, metrics, logs, and traces. It's only when you have all of those data available in one platform that you'll ever really have that full observability, that full end-to-end picture. All right, so what does tracing actually look like on the ground or from an implementation standpoint? One of the things that really furthered the adoption of distributed tracing was some of the open source tooling available. And so specifically as it relates to a framework for generating traces, we have something like OpenTelemetry, which is very much a framework, not a service. When it comes to ingestion and client and displaying those data, Jaeger and Zipkin are some of the most popular tools. And so these open source tools give you the great ability to sort of dip your toes in and try to understand what distributed tracing is. But they certainly have some drawbacks. And so when you're using these open source tools and these open source technologies, there's going to be a decent amount of manual work involved in actually getting these traces set up, right? And so you'd have to actually go into your code, pull in these frameworks, instrument every call so that it's actually collecting and sending data, create these spans yourself, specify which information to collect, and add context to your spans. And so it's a fair amount of work. There are also inherent limits to something like open tracing, primarily because it is a header propagation specific tracing tool. What do I mean by that? Header propagation is the idea when a service makes a request, send some unique identifier as a trace ID so we can stitch those requests together after the fact. But that does lead to gaps, specifically instances where you have, for example, let's say a node service that writes to Dynamo and that write triggers a Lambda. Because Dynamo has no headers, open tracing won't actually be able to trace through that full request path. And so open tracing, it's great for getting up and running, understanding what's there, but keep in mind that it does have some of those limitations. Of course, when it comes to ingestion and client in a live production environment, you have to be sure that it can do things like handle your scale, right? We work with customers who have billions of requests a day, and they need to make sure they have a tool in place that can support that. You want to make sure that you have all of the important information available to you, so having that payload information that you can really leverage for analysis. You want to be able to visualize those traces, and ideally also set up alerts for those traces as well, right? Be proactively alerted when something goes wrong. Now, we're out there in the market every day talking about observability, and so we've defined in some sense sort of best practices, if you will, right? If you want to enable distributed tracing within your environment, what are some of the things you should be considering? Of course, in an ideal world, you want it to be automatic in setup and have zero maintenance. You don't want to have to do that manual instrumentation that we looked at in open tracing. You'd want a tool or observability that supports all of your environments. Maybe that's Kubernetes, maybe that's ECS, maybe that's Lambda, and it should be able to support all of those. It should also be able to support those middleware pieces, right? Having the ability to trace through Kinesis or trace through Kafka. It should be able to search, visualize, and analyze all of the data being collected, really with an eye towards pinpointing problems, right? Observability is at its core about understanding what's going on throughout your environment and being able to identify and pinpoint these issues in a really rapid manner. When you're taking this journey around observability, a couple of key steps along that path, if you will. Of course, important to identify your business goals and your architecture. Maybe there's a use case, maybe due to historical precedent or whatever the case might be, where microservices aren't the right way to go. But if they are, observability and tracing is going to be absolutely key in achieving this observability. You want to determine how are you going to approach it, primarily buy versus build. Of course, there are the open source tools out there, but there are also a lot of hosted solutions where they're going to take much of the work off your plate. Of course, Epsagon being one of those, where we want to make it as easy as possible to get instrumented, get up and running, and ultimately get traces for your services. You need to then implement that solution, and then, of course, ensure that it does have that scalability as your organization grows. Ensure that the tool you selected can grow along with you. All right, now, why is observability important? It's important, from the technical perspective. As an engineer, having that level of insight is very valuable. But of course, what does that mean at the higher business level? That's ultimately going to drive decisions around, let's say, installing a new observability platform. Why should you do this? What do you achieve from the business level, if you will? It's really a couple of key things. It's around improving this developer efficiency as well as that user experience. Having these very complex architectures and applications, it can be very difficult to get that understanding, as we've mentioned, right? Let's say you hire a new engineer. How can you quickly get them up to speed? It's by having a distributed tooling in place, right? Having a tool that provides you with a service map that shows all of your applications and those relationships, so everyone can really have a shared understanding of what's going on. It's giving you that complete visibility into your modern applications, which is primarily going to help you reduce application downtime and lost revenue. One of the customers that we've had a long-standing relationship is a ride-sharing company called Via. Primarily, they focus on major cities, both in the US and Europe. For them, any minute of downtime equates to tens of thousands of dollars in lost revenue. And so this is absolutely crucial for them to have the tools in place when things go down to really make sure they can resolve them quickly, provide a better user experience, and ultimately save that reputation and revenue. And having this level of insight does allow you to really understand that customer experience, right? Maybe you have a customer who's making an API call into your system, and the latency is very high, right? Why is that? Maybe it's because of a long-running inefficient query, or maybe it's something else altogether. But knowing what that journey looks like, what that latency breakdown looks like, what their experience is going to really empower you to provide that best user experience. All right, and it's really, again, all about enabling that visibility. A lot of this we've touched on, so I won't spend too much time here. But again, it's all about allowing your engineers to focus on what's important for the business, which is building out new features and functionality, right? Using Via, again, on average, their engineers were spending half a day per week doing troubleshooting. They cut that down significantly. And so that's a lot of time and resources that can now be reinvested ultimately back into the business. All right, and by doing that, by making that investment, by having that time freed up, you're really going to reduce those operational development and opportunity costs, right? And so some of the challenges we see around legacy solutions, they're very heavy in their instrumentation. They don't necessarily scale well. They have significant overhead that impacts their user experience. And so, of course, you want to look for a tool that can be instrumented out of the box, that can scale for you, that can do it in a way that doesn't add significant overhead, an impact that you would see, again, for those users. And it's really, again, with an eye towards reducing those costs around things like monitoring and getting to spend more time on the core focus of that product innovation. And so these are the reasons that ultimately the customers we work with choose Epsagon, because it allows them to achieve these outcomes as we see here. All right, so in summary, we can see, and I'm sure everyone here has perfectly recognized, there's been this huge transition over the past, let's say, 10 years, moving from these monolithic on-prem applications to these distributed architectures. Again, it's done for a very good reason, both cost savings as it relates to leveraging cloud technologies like AWS or Azure, but also because it does increase that developer velocity. It allows you to roll out new features and functionality at a rate that simply wasn't possible in that monolithic era. And then key to that, once you make that transition, as you're doing that transition, have that observability strategy already built, right? If you're in the process of doing this long migration, of moving from a monolith to these distributed architectures, plan it out in advance, have that tool available to support you. As you're shifting those services, you'll know and you'll have that insight to make sure it's done properly, and it's done in a way that really ultimately allows that transition to go as smoothly as possible. All right, awesome. Thank you all very much, again, for taking the time out to attend our session here. Now I'm absolutely happy to answer any questions you might have. Please do take some time if you want to look at a special offer for our viewers, and simply go to epsagon.com/devweek. All right, awesome. So I do not see any questions in the chat currently. We'll stick around for a few more minutes. If anything pops up, feel free to drop it in there. Again, otherwise, I hope everyone has a great day.